Hello, everyone, and welcome back to a new episode of Advent of Code. We're going to start on day 3 in a minute, but just like I did yesterday, I'd like to take a moment first to revisit some of the previous day, some things that I worked out in between finishing the last puzzle and starting this one that I think improved the solution a bit. So I made, I think, 3 commits here. The first one was pretty simple and didn't really change much of anything. I had remarked that, like, gosh, it's kind of, silly to take in these two things as separate entities and then return them as a pair, because it gets, like, awkward to, like, iterate with this, and wouldn't it be nice to be able to iterate? So I changed tick to take its arguments as a tuple, and I swapped their order so that they're in the same order as what we're returning. Obviously, once we make an int code library, we won't be using tuples like this. We'll have a data structure that contains all the relevant stuff. But for now, this was fine. So changing tick was pretty simple, and changing run to use the new tick was pretty okay. I also replaced the case analysis with a call to maybe, which is much nicer, I think. So maybe is actually, we were talking about morphisms in the last episode. Maybe is actually the catamorphism for maybe types. And so it takes 2 values. Well, let's actually just ask GHCI, right? How do I get it? Yeah, T maybe. So maybe it gives you back a value of type B from a maybe of type A. And in order to do that, it needs a B to use if the result was nothing. What am I doing using the mouse? I hate highlighting stuff with the mouse. And an A to B to use if the maybe was a just. So I realized that here I was kind of just implementing maybe somewhat badly, right? I was matching on nothing and returning program, matching on a just and returning the first item if so, or returning, I guess, both. Calling go on both, yes. And now that we've turned it into a tuple, I can just pass go as a function instead of needing to, like, destructure and restructure. So that's sort of nice, I think. And I think that's all I did in this commit, yeah. The next commit was to, rather than having run do all the work of, like, ticking multiple times, detecting a stopping condition, and returning the result that we care about from that stopping position, I refactored into states, which takes a noun and a verb and a program and just gives you a list of all the states that program ever enters. And then run just calls states and, like, gets the program that is the last value of the result of states. Pretty simple in concept. States has most of the stuff that used to be in run, but it's got this, like, map from just.takewhile is just, which I don't like very much. I'm sure there's something better. And iterate with binding tick is kind of cute, right? That unwraps, that's an iterate step that unwraps the maybe if it was a just and continues, and otherwise short circuits and stops. So if it's, well, not stops, it'll return nothing, 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 which is kind of lame. And that's why I have take while is just to throw away all the states that never happened. And finally, I did the thing that I kind of talked about wanting to do with part 2. I remarked that part 2 is the only place I'm doing any manual recursion. And I've been trying to practice, like, not doing so much of that. And oh wait, no, that's not true. Part 2, it was here in this commit where I did that, right? Instead of having go refer to itself in the old version of the program, now states uses iterate to do the recursion, and run just calls states. So there's no longer any manual iteration or recursion or looping of any sort. It's all delegated to library functions here. I thought about how to do it with, like, recursion schemes morphisms, but I mean, like, in principle, like, this iterate is kind of an anamorphism, and take while is a catamorphism, and you can glue them together into, I think, a hylomorphism if you want, but like, I don't know, iterate and take while already exist. Why reinvent them just to frame them as a recursion scheme? I'd rather not. No, what I did here was remove the do notation because I didn't really like having to like bind to noun and then bind to verb, and it kind of felt like lift A2 ought to do the job for me, and it sort of does. But this construct here is kind of equivalent to a lift A2, right? It takes the tuple function and calls it on each pair of elements selected from these two ranges. But you can't just lift A2 solve, which is what I at first tried to do, because solve needs to return a monadic value, not just a pure value. So we have to bind to solve instead. Okay, whatever. Anyways, that's what I did in between yesterday and today. And of course we still get the same results, right? Great. I'm a little bit hopeful that we're not going to have more int code for today's puzzle, just because I want a little while to figure out like what the deal is with. Because really, like, I should make a library for myself. That's like my int code library that I develop as we keep going. I don't really want to do that today, but maybe I will if it turns out we need it. Anyway, oh, almost hit the end recording button instead of the switch things button again. See, I'm just more used to pressing that button, right? Because I more often end the recording than like, well, when playing Advent of Code, I switch screens all the time. But when playing like a game, I don't switch screens and I end the recording at some point. Anyway, here we are, day 3. Crossed wires. The gravity assist was successful, and you're well on your way to the Venus refueling station. During the rush back on Earth, the fuel management system wasn't completely installed, so that's next on the priority list. Who's rushing back to Earth? Is it Santa? I think so. Are we, like, going to go... Oh, back on Earth, not back to Earth. Got it. We didn't finish installing the fuel management system. Okay. Opening the front panel reveals a jumble of wires. Specifically, 2 wires are connected to a central point and extend outward on a grid. Okay. You trace the path each wire takes as it leaves the central port. 1 wire per line of text. Text? Oh. Per line of text in our puzzle input. Okay, so we're tracing 2 wires. The wires twist and turn, but the 2 wires occasionally cross paths. To fix the circuit, you need to find the intersection point closest to the central port. Because the wires are on a grid, use the Manhattan distance for this measurement. While the wires do technically cross right at the central port where they both start, this does not count, nor does a wire count as crossing with itself. Okay. So if the first wire's path, starting at this central port, it would go right 8, up 5, left 5, down 3. Okay, so our puzzle input is actually this. It's not a grid. It's this, right? Yeah, okay. So we need to find all the places okay, so we get 1 line of text per wire, is that correct? Yeah, 1 wire per line of text, got it. So we'll get 2 lines, each of which describing the turnings that 1 wire takes. And they say right and left and up and down. Those directions feel a little bit too relative to me, right? Like as in turning right. I'd rather call them north, south, east, and west. Those are clearly absolute. Okay, so seems like an easy thing to do would be to have a function that takes in one of these sets of instructions and produces a set of all the points that it ever visits. Call that function twice, compute the intersection of those 2 sets, and find the one that is smallest Manhattan distance wise. That seems pretty simple. That's pretty clear. There's probably something more clever that doesn't need to store intermediate points somehow, but I don't see what it would be, and I'm not smart enough. So I'm just going to do the obvious thing of just getting a set. This is the kind of thing that feels like a scanl, right? We're sort of folding a state, which is our like beginning, which is our coordinate, over a set of instructions, and we'd like to keep track of all the results that it had along the way, and that's what scanl does. What other features of this strike me as like useful abstractions? I mean, a position is... no, not a position. A delta is kind of monoidal, right? Like if you add together two deltas, you get another delta, and 0, 0 is the identity element. So like fold map could be a thing that's relevant, or mconcat maybe. But I don't think that's going to be so useful, because we don't want to know like where we ended up. We want to know all the spaces along the way. I don't know, I guess we could build a list of one element deltas and scanl them all together using like mappend, basically. That seems pretty reasonable. So if we have a pair of sums, what is sum? All right, let's I want to look at let's get over to day 3 here. Okay, so what is the, not day 23, get out of here. Yeah, kill the whole session and the buffer, get out of here. Day 23, my eye. So what is the, tell me about tuples. What I want to look at is the monoid instance. Okay, that's not quite what I want. Oh, it is. Oh, there's 2 instances. So first you can have, I see. If, well, how can, oh, no, this is a monad instance. This is the monoid instance. They both require monoid, but oh, okay, perfect. So this is exactly what I wanted. I wanted to double check that monoids do have a pairwise instance for tuples. And that means that if we store a pair of points or a pair of sums, then mappending them will work. So what I'm talking about here is import data monoid sum. I guess I also need get sum, right? And so suppose that we have like sum1, sum5, and we want to append that with sum 8 or 9, whatever, sum 2, right? We get, yeah, of course, it's an integer, whatever. We get back a sum. So the point is that we can just kind of say, I have a pair of numbers and I kind of intend them to be summed together. And then if we have a list of such things, mappend will like do the right thing and give us sums. So we don't have to write the like tedious packing and unpacking of tuples and using addition. We can just get that for free using the monoid instance. So one function that it seems like we will clearly need, oh, let me get my input, by the way. Okay, great. One function that I would like is intermediates should be it should take a list. Well, technically any foldable would be okay, right? So let's let GHCI tell us. Let's let GHC tell us what the type should be. So the intermediates of a list of x's, let's say, should be scanl, mempty, append of x's. And in fact, I can A to reduce this. It'll tell me now, right? Yeah. So what is the type of intermediates, please? Hey, what are you mad about? Will you tell me what type this hole has, please? Scanl only takes lists? Why doesn't it take a foldable? What? Obviously it's fine for lists, but Haskell scan foldable. Okay, someone's written a package called foldl that includes a module named scanl, but that's not really what I meant. Huh. Well, okay, whatever. I guess we'll just use it at list. That's fine, I guess. Monoid m and an it'll take a list of m and produce another list of m. Oh, I gave scanl the arguments in the wrong order, like a weirdo. So if I had done it correctly, would I have gotten... To use the inferred type, enable partial type signatures. Okay, but why isn't it inferring the... do I have to say this to tell it that I also want it to infer the constraint? Oh, it does, yeah, okay. So it says, okay, this constraint is monoid B, and this is B to B. So it'll tell me what type. Like if I can't figure out the whole type, it'll tell me the rest. Okay. So the idea here is then that we could say. Let's import data.monoid here as well. So that I also have it in GHCI. So if I say like intermediates of this list, I get back another list of all the places you would go if you followed these directions starting from the origin. First you're at 0, then you're at 1.5, then you're at 10.7, right? And if we put more things in here, like you know what? Let's just not write all these stupid sums. I'm tired of them. Of course, we have to get them in. Haskell has to somehow know I want a sum, but we can do that just fine. And let's say 8, 8. I don't know, just to demonstrate the concept. This won't work because, oh, it does work. It just doesn't know what type to use. First of all, this doesn't work either, right? Yeah, there is no... Oh, hang on. What I meant is this. Yeah, because... Oh, I want it to be a list. It does work. Okay, so there's a num instance for sum. That surprises me a little bit, but okay. Yeah. So we just say, here's some numbers, and by the way, I want you to treat them as sums and give me the intermediates. And if we wanted to, we could do some kind of wild stuff and say, I'd have to import it, I guess. I'll just do that in GHCI. And look at that. Now it's multiplying together the first half of the pair and adding together the second half, just because we said, like, that's the result that we want. Pretty cool, right? And we only have to say it through the types. Now, this is not all we want, obviously, but I notice it starts out at 1, 0, because 1 is the neutral element for multiplication and 0 is the neutral element for addition. Obviously, we're not going to do that today. We're just going to be working with sums, but it's cool, this kind of like type-directed something. I don't know. Type-directed programming? Not really, but so anyway, we're going to want this intermediates, and the other thing that I will want is something that accepts a pair of numbers. I want something that turns a number like, 5, 0 into like 1, 0 5 times, because then intermediates can consume such a list and produce all the places it's ever stopped. So as units of, yeah, I can just put a 0 here. That'll work. 0 n equals I guess if n is greater than or equal to 0, then we want replicate n of 0, 1. And if it's negative, and as units of n0, similarly, otherwise equals replicate negate n of -1, 0. And what is the type of this, please? Yeah, I know they're inexhaustive. Non-Manhattan movement. Top level binding with no type signature. Oh, it even tells me the signature. Yeah. Okay. Int to AB? Yeah, but I'd rather it be integral A. All right, so this is an accurate type, but not the one I want. I want as units to, provided that A is an integral type. Actually, is sum A integral? I'm not sure. Let's just use num A and eq A should take a pair of A's and produce a list of pair of A's. Oh, n might be okay, so can I write, it should work for integral, right? This is now, oh, replicate wants an int? I see. Okay, so first question that I have is, get me out of here. I wanted to see the REPL. Info sum. Is it integral? No, it is not. Okay. So let's just use num, and that's fine. And now tell me about num. It has from integer, but it doesn't really have a to integer. Maybe I'm getting kind of silly just working with sums and not doing anything with ordinary integers. But I kind of feel like that's the right thing to do at the moment. I could just rewrite this to take a pair of sums of ints and return some sums of ints. But that's not very satisfying. Although, you know what? That's actually fine. The inferred type was actually pretty cool. Now that I think about it. Replicate wants an integer? No, it wants an int. Okay. So the idea is that we don't have to work with some ints all along, right? We can have as units be the thing that does the conversion, right? We can call, now let's demonstrate. As units of, say 5, 0, and give me the result as a list of pair of some int, right? We get back 5 of them and they're all ints. Looks like 5. Hard to tell for sure. Should be what, 9 total commas there if there were 5? Yeah, good. Okay. So the 1 and the 0 here have a polymorphic type. They're not just integers. These types actually are constrained to be integers because we're using them to call replicate, and replicate only wants an int. But since some int has a num instance, we can convert 0 to a sum of int just fine. Oh, all right. I'll call it an underscore if you want. So, what else will be useful to have? Well, sort of... I'm just so worried suddenly about what part 2 is going to be. There are a number of things part 2 could be that would make a lot of the work I've done so far sort of useless, I think. Like if they say, oh, actually this was about turning. It wasn't north, south, east, west. Now suddenly things aren't monoidal at all, and I feel pretty dumb. But I guess we'll cross that bridge if we come to it. So what would also be useful is... like, we need some kind of parse function that's going to take a line of text from the input and turn it into a list of vectors, basically. And I mean, the most principled thing to do would be to define a new data type that's like got 4 alternatives, right, up, down, and left, and parse into like a vector, which is a direction and a magnitude, and then convert from that to like this kind of low information pair type. That sort of seems like a lot of work. So what if we just wrote a function read vector that takes a string and, I mean, really it ought to return a maybe, right? Maybe int. gradient. And honestly, like, this is just too small a problem to even bother importing parsec. So read vector of direction cons to magnitude is case direction of left, you know, something, which I guess would be, okay, how are we orienting? How do we want to choose to lay out this coordinate grid? I guess it's kind of funny. Like, the obvious way is like, okay, x vertically, or x goes like this, y goes up like this, and that makes sense when you look at like a graph that you would draw that has like an origin in the center, right? That like you would draw a parabola on in middle school or something, right? But the other kind of somewhat popular coordinate system that computers often use has 0, 0 starting at the top left and gives the y first. So like this tile here would be at 3, 0, and this is at 3, 2, and so on. I think that is a coordinate system that makes sense only when 0 is actually a boundary, when there is nothing to the top left of this. When we're working in an infinite grid, it makes sense to model, like, to treat it just like the kinds of graphs you would draw in like geometry class or whatever. Algebra? I don't know when they give you graphs. I guess algebra, right? So I think we will have x first and positive to the right, y second, and positive going up. But this is a choice we can make freely and do whatever we want with. So left is going to be oh, I should be a little more careful here, huh? I'll just say do here. Is there like a read maybe or something? There should be, right? Haskell read maybe. I know there is, but like where is it? It's in base in text.read. Is that imported into Prelude normally, or no? So ambiguous type variable, yeah, okay, but you knew it was supposed to be readable, fine. So if it's this, then we should return mag 0, right? And now it'll type check. Oh. I guess pure is also wrong, isn't it? Because we might discover the direction is not one of the things we support. Okay, pure goes here then. Right to be pure of 0, no. Negate, actually, is it minus mag? Or is that, I can never remember which one is a tuple section and which one is negating it. Okay, so you can call minus. Why is this type checking? Let x equal 1 in minus x 0. Defaulting. Okay, well, you know, it works. So there's some weird special case for parsing negation Because like minus is the only thing in Haskell that is both a unary and a binary operator, and it's super weird. And like x minus, this is also legal, right? This is, you're now treating minus as a tuple section, or well, I guess this would be legal. Anyway, but this has a different type completely. Super weird, right? Anyway, apparently you can just write this. I write negate a lot of the time to be safe, but apparently minus works in this context. And it's only, I don't know. And up is pure of 0 magnitude. Down is pure of 0 minus mag. And otherwise is nothing. Now read vector should be happy, right? What are you mad about? Oh, there might be no things. Good point. Okay. Read vector is yellow, but it's a mistake. So if we now say like read vector of R5, we get minus 5, 0. Seems pretty good. Now what? We're getting close to writing part 1, of course. I guess we want... Ugh, there's all this splitting on commas again. Like... Well, I guess we'll just look that up real quick. Haskell, like, split string on delimiter. Like, what the heck? Come on. Data list split on. Yeah, but that's not part of base, but I guess I should depend on it. Because it's like, there's a lot of useful stuff in here, I suppose. Okay, so let's just add that dependency. Package split, right? Yeah. PQRS. Oh, no. Oh, right. That's not my Windows paste buffer. Oh, so I'm gonna say I want split, and it figures out the version for me. Great. Yeah. Please restart GHCI so we get this new. Yeah. Ooh. What are you mad about? I don't even know. Cannot satisfy package. Split. Okay. What? Stack build. A stock. The German stack. Yeah, there's something weird like. Oh, I don't know exactly why it is that. Yeah, just kill all these stupid processes. I don't know why it is that Emacs can't handle that reload, whereas stack can. But like, now we have data list split, so. So what I want is like, parse is a function from a string to pair, or list of pair of int and int. Maybe such a list? No, we'll just use cat maybes. It'll be great. We'll just silently drop all input that does not conform. I can't imagine anything bad could happen as a result of that. Cat maybes composed with map read vector composed with split on wait, is data list split not what I want? I can split on like lists, and I guess I can just pass. I can just pass a list which is a single comma, but I don't understand why I can't split on a single comma, like as just an A instead of a list of A. But whatever. I mean, I guess it works, right? What are you highlighting this for? Use map maybe. Huh, I didn't know about map maybe. Cool. So now if we say parse of, and let's go grab an input from the puzzle, from the example page. We get this. And that looks about right, doesn't it? Cool. So what is prepare exactly? Prepare is probably just map parse of lines. And our input type here is a, well, map means we should be willing to accept an arbitrary number of wires, which I guess is fine. We'll just look for the places where all the wires meet. And if there's more than 2 wires, there will probably not be many meeting places for all of them. But that's fine. So our input type will be a list of int and int. Right? For each wire, the list of directions that it should take. Part 1 of wires equals something. Let visited equal, I don't know, do is probably fine. So choose a wire from the wire. This will probably just be like a dumb version of word. I can't type while I'm talking. This is just gonna be like, I don't know, a pretty dumb use of a list comprehension, I think, but sort of helping me get my thoughts out properly to write it this way, and then we'll refactor it to look nice, probably. So for each wire, and here wire is a list of pair of ints, and happily we have a function so we want to map concat map as units. Let units equal wire yeah, I don't think I want to bind again. I want to bind inside this scope, not as a new monadic operation. Wire bind to as units. Now we have all the places that this, a single step for each, a single pair for each place this wire would go. And then we want to return s.fromList of intermediates of the units. s.to list of this just so I can get a look at what. This is fine. s.set of some int, I guess. So what is it? We have a list of such things. List of, in fact, pairs. Okay, so that's you're right. This is an invalid type. I have a list of pairs of some event, right? Yeah, and apparently sets are printable. So this parses. This type checks and everything. Kind of surprised. So, okay, yeah, you can stop now. We printed a lot of things. I guess I should have just asked what the size of them was or something. All right, well, see you later, Emacs. It was a nice run. I guess I shouldn't have killed the buffer, whatever. But the point is, that worked. So let's just turn a list of int instead. What, oh, is it? It doesn't know what type anything should be because I'm not using it in the return type? That's true. S.set of, I don't know, this is kind of silly. And it's actually a list of those things. Oh, you can't put a type signature there? I guess that's fine. I'll just move it here. Yeah, you're right. I sure don't need the $sign there, but that's not the point. We're not leaving this expression in. We just see, okay, each of these visits about 151,000 places. Should be no trouble to intersect those, right? And then find the smallest intersection. So let's have a look at the operations in data set. I want to combine them with like intersection or something, right? The intersection of two sets. How come we have unions, which takes like a list of things, but not intersection? I mean, we can fold L or fold R, I guess, with intersection to. Oh, it's actually kind of hard. Fold R1, does that exist? Yeah, it does. Okay, a bit tacky, but that's fine. Yeah, so we have a list of sets. In principle, there should always be exactly two of them, but my sloppiness with using lines and you know what? Actually, we should. No, it's kind of nice actually that there's a list of them, because then I can do this like list comprehension instead of having to handle the two of them separately, right? So what am I thinking? What am I saying? Fold R1 S intersection of visited this should be like a list of pairs. Oh, it's a set of pairs of ints, which is fine. That's what I expected. And what I want is minimum by, which is in data list. Minimum by xy abs x plus abs y. Minimum by takes a comparator. Is that right? Oh, compare. I guess I'm going to want to use comparing, right? So we have minimum. Yeah, it wants a function that produces orderings. So where exactly is okay, it must be in data ord, I guess. Okay, yeah. And then now I just want some sums. So I think main would actually do what I want now. Well, I mean, I guess let's try it, right? 0, 0. Yeah, you got me on that one. The problem did remind us that 0, 0 is technically a place where they cross, but not a place that you should include. So what we just need then is like, when we call intermediates, we should also call like tail. Because we know there's at least one element, and the first one is one we don't care about. And I think this is the right place to do that dropping. There you go. 610, 675. That seems plausible, right? What is the Manhattan distance? Oh, I don't need to know the actual point. I could have just said add them up. So it's what? 1285? Yeah. That's the right answer. Great. So let's see. I don't have anything particularly clever to say about this. Just day 1 part, or day 3 part 1. And let's. Oh, sorry, you guys didn't see. I committed. Nothing very exciting. Continue to part 2. Turns out this circuit is very timing sensitive. You actually need to minimize the signal delay. To do this, calculate the number of steps each wire takes. Oh, that's so easy. Including the intersection being considered. Ooh. Maybe it's not easy. The total number of steps is very easy, but the number of steps it took to get somewhere, now that's a little trickier. So, calculate the number of steps each wire takes to reach each intersection. So, it's quite difficult, I think, to do this all in one pass, right? because you need to keep them in a list, basically, to keep track of how long it took to get somewhere. And, well, you can keep them in a map keyed by something. Yeah, like a map keyed by position that stores the distance to that position, I guess. Okay, so anyway, what is it? What is the actual result that we want? The fewest combined steps the wires must take to reach an intersection. So, okay. It's very useful still, I think. Well, no, we don't really need a list at all anymore. Right, in this version, what we kind of want is two maps where the value stored is how many steps it took to get there for the first time. Then we can find the intersection of the key set of those maps, I guess. How do you give me the data.map API, I guess. Data map, lazy. I mean, I don't know. We could probably use a strict map, but so is there a way to like get intersections basically between two lists? Combine intersection intersection with a combining function. Oh, how juicy, right? So we could compute, instead of a list of all the places they visited, which is then being converted to a set. Okay. So in both cases, we want to compute a list of all the places they visited. But instead of converting to a set, we'll convert to a map where the value we're enriching with is how long it took to get there. Okay, that seems pretty simple. So, in fact, we could reuse that, like, we don't even need set at all anymore, because part one could work just as well with a map, right? Although, yeah, that would still work because it can just ignore the value at the key, and yeah, okay, that's fine. So everything outside of here doesn't really need to change. We'll just extract. Put a space there for no reason. We'll extract some of the stuff from part one and make it a little helper function that they both use. Visited of wires equals do, like, I mean, this, right? Except we don't need to call. Oh yeah, we do need to call pure. We don't want to call s.fromList though. I kind of want to reuse the name visited, right? Spaces equal visited wires. There you go. Oh yeah. So now the problem is we're not returning a set anymore, and so part one has to change a little bit to Oh, we're not even using... Okay, get out of here, sets. I hate you, sets. My new love is map. Which I guess goes up here. No, forget it. I'm putting it on its own. It's like a separate thing. I don't know why. So there's only one place left where we use set. And m dot intersection... Oh, hang on. Visited needs to... Right, it can't just return a list. It should now return actually a map. And then we should use that in part 1 and part 2. So visited should, lowercase visited, should take a list of, no, an input, which is a list of wire basically, and produce a list of list, right? Yeah, that type is correct. Good. But, oh god, that's what it is returning, but it's not what it should return. It should return a map from pairs of sums of ints to an int, which is how long it took to get there the first time. And so instead of just... Oh no, input... What is the type of input? List of pair... List of... Yeah, that makes sense. Oh, I can't use do notation anymore. Okay, I can, but let... m dot from list. What do we have in math that makes lists? I think we just want from list basically, right? Creation, where construction from unordered lists. Oh, from set. How interesting. But no, we want from list. Yeah, it's fine. Oh, what does from list do? The last value is retained. Well, that's not what we wanted at all, really. From list with takes a combining function, and I can just use the first one instead of the second. So from list with const should do it. Yeah. Okay. So m dot from list with const zip flip zip, like so. Almost type checks. What's wrong? Yeah, I guess you're right. It's not returning ints. Oh wait, it is. It should be, right? So this do is returning a list of lists of pairs of sums of ints. We're actually returning a list of these things. So I want to map this over do. There we go. Yeah, so for each wire, we're going to get back a thing that we want to turn into a map. What a wild function, huh? You know, this whole do notation thing is actually like just one fmap somewhere. It's just a... No, that's not true. We have two binds, so it's not one fmap. There's a bind and then an fmap somewhere. I'm surprised HLint isn't complaining about that, actually. Like, shouldn't I just write, like... this? Yeah, that type text too. And now I don't need this pure because I can replace it with that fmap that I was talking about. Oh, but I need to flip the order. This is why I'm a fan of the using this operator instead of this one, is because then it's the same order as fmap. But okay. So this is like reasonably readable, I think. And now m.intersection it has... Oh, I can just ask. I don't need... I'm still not used to like Haskell or Emacs telling me the type at the bottom of the file. What is... No module? Because I couldn't compile it undefined. Take that. Now it's mad about this stuff. Yeah. But okay, what's the type of m.intersection? God, you're killing me, Haskell. Intersection takes two maps, and that's all. Fine. Returns a new one. So fold.our intersection has given us a map, and we're ignoring the values. So how do we get from a map, then, its keys? I guess that is conversion to a list. Yeah, it's just a function called keys. And what did I have typed here before? Spaces. There you go. So if we now were to run main again, fold L1 empty list. Well, that's what I get, huh? I wish I knew where that empty list was. I definitely am not like great at debugging Haskell, but it must be coming from fold R1, right? Like our intersection must have somehow failed. How could we inspect what has happened here? Wait. Okay, first of all, let's call this traces because spaces is really weird. Right, spaces suggests it's a list of spaces, but it's not. It's a list of, for each wire, a trace of all the places that it visited. So tell me about debug trace again. Like trace takes a string, trace. working a minute ago, right? We haven't written part 2 yet, so it's not like something in part 2 can be breaking us. Alright, let's just comment out this type signature so I can write whatever stupid junk I want here. And then, instead of returning all this, let's first do something really obvious and say, like, in length traces. Like, this should really be 2, right? Anything else would be a shock. Excuse me? 602? Okay. So somehow we've convinced Haskell that we have 602 wires. Okay. So there are 2 wires, but when we trace them with visited, we get back 602 things. Ah, I see. We're nesting lists incorrectly in visited. But why? So we choose a wire, and we want only one output for that wire. Okay, clearly the rewrite that I did here was all wrong, and I don't really understand why. So can I have the old way back, please? No further undo information. Well, that's too bad. Yeah. Okay, well, whatever. Like, this currently type checks and is still wrong, right? Yeah, it's saying I should use fmap, which I think I agree with. But, like, let's just test. Does this actually fix it? And I don't totally understand what I'm doing with that rewrite? No, there's still 602 of them. Okay, so what is it we want to do? We choose a wire. And then we say, yeah, okay, I think the map needs to move inside here somehow, and I'm not sure exactly how. In fact, maybe it's just like this? No, I don't know. Stop just typing stuff and seeing if it works. Start thinking about how things should happen. So, let's say like spaces visited is equal to tail of intermediates as units of the wire, right? Oh, I probably just shouldn't be binding here at all. No, but that was... So this works so far as it goes. Now this fails to type check. Which is sort of interesting, isn't it? Visited takes as input an input, right? Which is a list of list. Ah. Okay, I think we need... We need something like this? Yeah. So we did need a bind here, but it wasn't supposed to be part... So for each wire, we compute all the spaces it visited, and then we return that list. So I think what was in the wrong place was actually our pure. So if I now run main again, asking for length of traces, I should get back 2, right? Yeah. Interesting. So I could just put a pure here. Yeah, the problem was before I had the pure in here instead, basically. And I was just like binding to pure, which is like return nothing, which is just like do nothing. Okay. So suppose that I now go back to what I had before and run my main again. -1, 0. Well, that can't be right. Oh. No. I'm getting out the keys after intersecting. All right, let's debug this a bit more. In foldr1 m intersection of traces. Like, what is all the places where they meet? Too many, huh? Way too many? Actually, I don't know if I did want to kill the whole session or not. Oh, it finished. Very funny. No, it didn't. Unbalanced parentheses. Okay. All right, good. So we actually still have our REPL, which is sort of a surprise to me. So there's only 2 traces, which are keyed by the places that we got to. And when we intersect them, we should get back a very small number of things. But we don't seem to, right? Like, let's just confirm. They cross 3,924 times. That doesn't seem so unreasonable, to be honest. I guess it seems a little unreasonable. What's our input look like again? Like, I mean, there aren't 3,200 commas in here, right? So you could certainly see this happening if they had like, if they coincided for a while. if they're both traveling along the same path, you would get this. Let's just like the length of the first trace. It's 3,960. So the fact that 3,924 of them were intersections should be like a bit of a warning signal here. Do I misunderstand what an intersection is? Data in the first map, 4 keys existing in both maps. Oh, intersection with const is already what I wanted. It's already the default intersection. Why did I somehow think that the second map? Never mind. I guess that's something to think about later, I think. But how could there be 3,900 entries in the first wire and like also 3,900 intersections when intersecting them together? That's kind of a surprise, isn't it? This is the worst kind of debugging. I am so bad at this. Yeah, 3,935. So like almost all of them are intersections according to this. It just makes me think I'm completely lost about what intersection means. But I'm not. I know what an intersection is. So fold R1 m.intersection of traces. We tried this already, right? And it was the one that returned like 3924. Yeah. Returns data in the first map for keys existing in both maps. I mean, maybe this isn't wrong, but it obviously is, because when we computed it before with sets, we were correct, and we did not find them overlapping at 0, 1. So something is actually wrong with visited, I guess, still. Which actually makes a lot of sense. We made a bit of a mess of visited. All right, so let's move this stupid map and make everything easier to see. So let's say do wires to wires. Let spaces visited equal. So for the wire, okay, so let's just write it in like super baby talk here. Let units equal as units of wire. No. Okay. Yeah. What? Why do you have to default anything? Oh, because I'm ignoring units and you don't know what type to use. That's fine. Spaces visited equal enter of units. Fine. Ambiguous constraint, that's fine. It'll all get resolved when we return something. So we have the spaces visited, and now we want to say pure of m dot from list. Oh, right. Intersection has the behavior I want, but from list doesn't. So from list with const. Couldn't match type. In a statement, in the expression. Oh, well, yeah, I still got this crazy map out here. So this, like, should be equivalent to what I wrote before. But it's sort of spelled out a little more clearly. And if this is still wrong, we can revisit this giant expression, I guess. Yeah, now there's only 52. So something in that rewrite is incorrect. Even though it looks equivalent to me, I'm getting something wrong in there somewhere. Okay. So if we do this again, we get back the correct answer. That is very puzzling. So let's actually commit this day 1, day 3, refactor part 1 to use maps in preparing for part 2. Okay, so now we can write. God, that was way more work than I thought it was going to be. Like, clearly I'm programming beyond the limit of my competence in this function, apparently. So now part 2 of wires, and I guess it's just going to return an int, right? What do they want from us in the output? The fewest combined steps. Yes, all we want is an int now. Part 2 of wires equals let traces equal visited of wires in. Now this time we want to look at the values in the map, right? So we need to compute their intersection, which is fine. So we could honestly refactor like this and this out into a helper as well, instead of repeating them in part 1 and part 2. Okay, so how do we turn a map into a list? Elms, keys, or the pairs in it. Okay, so we want like the second element of minimum by, well, no, we can just say minimum map second on the associations of fold R1 m.intersection of traces intersection? You don't like my return type? M. There we go. Oh, since we don't propagate the sum out anywhere, it doesn't even know what what type to use. Okay, fine. Oh, visisted. That's the problem. All right, so it actually does know. $77.36. That's not the right answer. It's too low. Well, yeah, that does seem awfully low, doesn't it? Or no, it seems high. Huh. Okay. Okay, well, I guess we can do one small thing that would fix this, which is to actually do the thing I was thinking of a minute ago. Let's just do minimum by. Please tell me what type this has. Ugh, I can't get to the mini buffer. There we go. Couldn't match. What's wrong with that? Oh, comparing. Again. Yeah. So it says that they're meeting at 274.1269, and they took 7,736 steps to get there. Is this because I dropped 0, 0? What does the problem have to say about these? Use the steps value from the first time, yeah. Including the intersection being counted. Okay, so that's interesting. But 8 plus 5 plus 5 plus 2. Oh, wait a minute. It's supposed to be the sum combined steps. I'm taking the number of steps it took for the first one to get there, but that's not necessarily, well, it's just obviously wrong. I was thinking they were going to be the same, but that's not true at all. So let's double check the requirements here. Number of steps each wire takes to reach each intersection. Choose the intersection where the sum of both wire steps is lowest. So number of steps. I think I'm probably doing something wrong with 0, 0 also. I may find that my result is too low by 2 even after I fix this. Or something's a bit funky anyway with how I handle 0, and I should double check that it's correct. So intersection with plus is what I wanted first. And if I run this, I'll get a different answer, but I'm not really so sure it'll be correct. It's about twice as high, which seems reasonable. So let's look at how I handle 0. I say the tail of the intermediates, and then I index them with 0. So I claim it takes 0 steps to reach the first non-intersection point. This is not really correct. So I should put the flip zip 0 here. So that each point gets labeled, even the origin. Origin labeled as having taken 0 steps. And then I drop the first one so that the first point is listed as taking 1 step. Now I sort of have reason to believe it might be correct. And it should be 2 higher than it was? Yeah. Obviously, I could have just added 2, you know, by hand, but I wanted to confirm that I was going to get that right. Okay, that's the right answer. So, another... Well, okay, let's go look at the calendar, right? Still not really clear what it's shaping up to be. Okay. Another one where, like, I'm not really used to taking this long in day 3, right? And, like, there are some things I could have done faster, some shortcuts I could have taken. I spent a lot of time explaining about monoids and stuff. But I kind of was... Like, I spent a lot of time actually not being able to solve the problem. And I feel like day 3 is not usually quite so hard, or I'm usually not quite so dense. Anyway, let's get rid of this excess information we don't want anymore. Oh, you know, we could just eta reduce all of this. Let's be super fancy, right? We don't need traces anymore. Right? There you go. Now it all fits on one line. Very lovely. So it's the smallest of the distances in the map, which is the intersection of all the places that we visited, that each wire visited. Kind of interesting. And we did solve it for like more than 1 wire, more than 2 wires, although the generalization is maybe not that useful. You know, how likely is it that 3 wires would cross even once? But if he gave us that problem, we would solve it. So that's kind of cool. Yeah, this visited. I feel like someone should study the transformations I did here, and as a result, I should know what I did wrong. I'm not going to do that studying, but if someone else wants to and let me know, that might be nice, I guess. Anyway, heck of a long video for day 3, and I think we should just git commit and sort of be done with it. I mean, I don't know. So this, I guess, was the transformation that I was making. Visited? Oh, no. This is just where I moved the flip. Yeah, something from before that. I don't think I ever actually committed the broken version of visited. Okay, anyway, yeah, still a little irritated about whatever it was I was doing wrong in here, which I think was having the pure in the wrong place or something, a bind in the wrong place. Anyway, that's all for today. Thanks for watching, and I'll see you next time.